Okay, now they want us to use the sequence. Look at the sequence here: 2, 6, 10, 4, 14, 18, and so on, to derive the n term of an arithmetic progression. So just like what I said the other time, and we have a formula for calculating the terms, of an arithmetic progression. Because for instance, if you look at this sequence now, this is the first, second, third, fourth, fifth. So you can't just keep on adding, I think, 4 here to get the terms. It will waste time. But for instance, if somebody asks you to find the 100th term, you can't just keep on adding 4, 4. So we have a formula for calculating, the terms, for deriving the terms of an arithmetic progression. So I'm going to use this sequence to do that. Okay, I'm going to use this sequence to do that now. So you realize that the first term, your solution, realize that the first term is 2. So first term, okay, we call it T1, same thing as A. So that is that's 2. That's 2. Okay, that's 2. Okay, then you realize that the second term, T2, is 6. And I can get that 6 by saying, I can get that 6 by saying 2 plus 6, 2 plus 4. 2 plus 4. Now don't forget that if you look at it well, look at the sequence where the common difference D equal to 6 minus 2. So it's the same as saying 10 minus 6, and the common difference is 4. So this one is just like saying, this second term is like saying the first term, which is A, plus D. Okay, so if you move ahead, you have T3 as 10. So I can get this as 2 plus what? Plus 8. 2 plus 8. Now the fourth term, okay, is 14. So I can get this as 2 plus 12. Okay, 2 plus 12. Now you have the fifth term. The fifth term can be gotten by saying, the fifth term is 18. So this can also be 2 plus 16. Now this is what I'm going to do now. So this second term, 2 plus 4. Of course, just like what I said, I can say this is equal to the first term, let me call it A, and that's A, plus the common difference plus D. First term plus common difference will give me the second term, that's 2 plus 4. Now you realize that these 2, that's A, the first term also. So I say A plus, if I multiply this difference by 2, 4 times 2 will give me 8. 4 times the difference will give me 4 times A will give me 4 times 2 will give me this 8. So just like saying the difference times 2, or 2 times the difference. This is the difference. The difference here times 2 will give me 8. So I can say this is 2D. Okay, this one also, we have A plus, I can say the difference times 3 will give me 12. 4 times 3 will give me 12. So this can be written as 3D also. So this one to the same thing, same process. The first term is still A plus, I can say the common difference 4 times 4 will give me 60. 4 times 4 is 60. So I can write it as 4D. So then you now look at the way the result is here. Then you look at it, this is the first term A, and when I move to T2, I realize that we have A here plus D. This is like saying 1D. Now T3 here equal to, of course, we still have A here, then but plus what? 2D. Now T4, you can see this is A plus 3D. You realize that this 3 is gotten by subtracting 1 from what? From 4. 4 minus 1 will give me 3. Even this one, 3 minus 1 will give me 2. This also, 5 minus 1 will give me 4. So you can just look at the order in which this one is from. Then you can use it to generate the nth term, that's Tn. So if I continue that way, I can arrive at Tn to be equal to, now just the same thing, you can see A in everything. So this is A, then plus, now this 4 is gotten by saying 5 minus 1. So 3 here is gotten by saying 4 minus 1. So if I'm to get the one for my n, then I can say n minus 1 also. N minus 1 times d. You can see we have d in everything. D. Okay, you realize this is a plus 1, 1d. And this also I can write it as a plus 0d. A plus 0d. So you can say this is a plus 0d. Of course, the 0 can be gotten by saying 1 minus 1. 1 minus 1 equals to 0. But there's no need to write this one. 0d 0. So 0 plus a will give me 0. That's why we only say the first term is a. So this is the formula for calculating the terms of an arithmetic progression. Okay, so the terms of an arithmetic progression. General formula for AP. So for instance now, if I'm to generate, let's say the 20th term, 1, 2, 3, 4, 5, I can't keep on adding 4, 4. So I can generate the 20th term. I'll just say T20. N is 20 in this case. We know the first term of the sequence to be 2. So just say first term 2 plus n is 20. Just say 20 minus 1 times the difference. The difference is 4. Okay, the difference is 4. So this will give me 2 plus 20 minus 1 is 19. 19 times 4. So we have 2 plus 19 times 4 is 76. 76. So now get it to 78. Okay, it's just as simple as that. So this is the general formula for calculating the nth term of an arithmetic progression. We still have the one for geometric progression also. All right.